Okay, I'm going to show you here on 13 of the review how we can use our calculator to find the equation for some data that we believe in the problem it says to be a cubic function. So we're actually kind of told which one to use. First thing we're going to do, bring my calculator in here, is make sure that we can put the year in the X list, or the list 1, and the guitar price in the Y list in list 2. But you notice here specifically, they've said don't put 1998 in, put it as time equals 1, put 89 in as time equals 2, time equals 3. And so in my calculator here, we're going to see that my list is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then the matching guitar prices go in here in list 2. And then now you can quit out of there and go to Stat and Calc. Okay, Stat and Calc, and you can do what they requested, the cubic regression. The cubic regression, and since I have list 1 and list 2 as my stuff, that's the default, I can just push enter. And there it is. I don't know if you can see that very well. Bring this a little closer. There are all the numbers for that equation. However, that's not easy to write down. In fact, I wrote it down here just to see how accurate we could be. I wrote it down to 1 decimal place in each position there off of the calculator. But then the question is, predict the price of an electric guitar in 1997, which is actually when T is 10. So I went to put 10 into this equation, and when I was accurate to 1 decimal place, it came up to be 673, which it is the closest option here, is 670, but I'd like to show you how to get to that more precisely. So we bring the calculator back in, and if we remember, we want to go to the calculators to graph. We put the variable that was just figured in here, so we're going to go to vars. We're going to go to statistics, which is option 5. We're going to go to equation and select regression equation. And what it does is it plants all that information we just calculated for the regression right into the y equals. Now I'm going to treat this like it's a normal window, so I'm going to go zoom 6 and graph it, and I see nothing. Because the graph is happening outside of this window, sometimes we can use zoom fit to get us close, but I don't know, we can try that. But zoom and then fit, which is option number 0, it will sometimes pull in something worthwhile and other times nothing at all. Give this just a minute though. Okay, now what I don't like about this is that it's not really a comprehensive graph, because what we want to see is where it hits the y-axis and where it hits the x-axis. So I definitely need to see more below, so I'm going to go look and see where it decided to go. Well, it said the y minimum should be 650, but it says the y max is about 4,000. I want the minimum to be about 4,000, so I can really see what this is like. And I'm going to take a look at that. Okay, that's not bad, but I anticipate that this turned around and it came back down through the x-axis. So I also want to see more to the right. So I'm going to change the window to maybe 20 or 30 here. I'll go to 30. There we go. Now I can see where it hits the y-axis, which is good. I can see it has maximums and it has minimums, and it hits the x-axis, which are called zeros. And the question is, what is the value of the guitar expected to be when we are in 1997, which if I look at the list would be when T is 10. So what I'm going to do is I'm going to go to second calc and go to value and just put in 10 for my x, which is the same as what T is calling for in the problem, and push enter. And it says in year 10, which is 1997, the price of the guitar should be expected to be $670.48. And so when you keep all those digits exact, or as many of them as possible, you actually do land on the option here more precisely.